Object-oriented programming, polymorphism. What is polymorphism? Literally, polymorphism means taking many forms by an entity or an object. It is derived from two Greek words, poly, which means many, and morphs, which means form. Polymorphism can be achieved in various ways such as through functions, objects, inheritance, method overriding, method overloading, operator overloading, etc. In this lesson, we will learn different techniques of implementing polymorphism in Python. So, let's begin with few simple examples that every Python programmer uses on daily basis. It will help you to understand what polymorphism is. Let's begin. The addition operator plus adds two numbers. The same plus operator concatenates two strings. When operates upon two lists, it returns a merged list. And when operates upon two tuples, it returns a merged tuple. Let's test the statements in the terminal. And here is the output. The plus operator is not capable of adding numbers only. It can perform various operations based on the type of the operands. That is, the plus operator is overloaded for performing different tasks in different situations. Now we will see that the multiplication operator, asterisk, is also overloaded. When operates upon two numbers, it performs arithmetic multiplication. But when a string is multiplied by a number x, it returns a string repeated x time. But when a list or a tuple is multiplied by a number x, it returns a list or tuple, where the elements are repeated x times. Let's test the statements in the terminal. The output clearly demonstrates that the asterisk operator is overloaded for performing different tasks depending on the types of operands on which it operates. Now we will demonstrate the polymorphic behavior of built-in len function. Just follow me on while I type few statements using len function. In these statements we are trying to find the length of a string, a list and a dictionary. As the output shows, when we pass a string as an argument to the len function, it returns the number of characters in the string. For a list, it returns the number of elements, and for a dictionary, it returns the number of pairs of key-value items. That is, the len function is polymorphic in nature. The return value depends on the type of the arguments supplied to it. Now, we will quickly see that range function, too, behaves differently when different number of arguments are passed to it. So, it's also a polymorphic function. So, these are a few examples of polymorphism in Python. Now we will see how we can implement polymorphism in our own applications. Here, we are defining a function, volume, that will calculate the volume of either a cube or a cuboid. If only one argument is passed to it, it will calculate the volume of a cube, but if 3 arguments are passed, it will calculate the volume of a cuboid. To achieve this, we will use default arguments. Just follow me along and see the code that I am writing. Carefully observe that we have set the default values for breadth and height to 0. We know that the length, breadth and height of a cube are the same, so only height is sufficient for calculating the volume of a cube. But for cuboid we need all the three. If all the values are zeros, then we need to return an error message or error code. Here we are using error code -1. Let's run the code and check the result. As we can see, the function volume is working fine. So, we can say that the function is polymorphic, it behaves as per the number of arguments supplied to it. Polymorphism can also be implemented by defining methods with the same name in similar types of classes and calling the methods through a common interface such as through a loop. Here, we are defining two classes, deposit simple and deposit quarterly compound. Both of these classes will have a method each for calculating interest amount. So, let's first define the classes. Carefully observe that both the classes have a method named interest, but their calculation is different. One is for simple interest and the other for compound interest. Only the method names are the same. Now let's create one object each from each class. Now we will access the object's methods from a common for loop. Let's run the code now. And here is the output. Now we will implement polymorphism using inheritance and method overriding. Method overriding is the technique of redefining a method in a child class that is already defined in the parent class. Sometimes this is useful for changing the behavior of a method in the child or derived class. In this example, we will define a base class, circular shape 3D, and 4 more child classes, sphere, hemisphere, cone, and cylinder. Our purpose here is to calculate the volume of spherical, hemispherical, conical, and cylindrical objects. Just follow me along while I code. As you can see, we have created 4 child classes from the same parent class, and each child class has their own calc_volume method. The names are the same, but the inside codes are different. Let's create objects of the child classes. Now we will call each object's calc_volume method for showing their volume. Here, we are using fstring inside the print function for formatted output. Carefully observe that the print statements are very much similar, only the object names are different. This way, using polymorphism, we make our codes more intuitive. Now, let's implement operator overloading. Here we will define a class, donation, and create objects of type donation. The objects will hold only an amount, that is, the donation amount donated by someone. Though we will overload the plus operator to add the donation amounts. This addition is possible as we have overloaded the plus operator. Without this, this operation will fail. For overloading the plus operator, we have used the magic double_add method. Magic methods are the special methods that start and end with the double underscores. Many magic methods are defined in built-in classes. For example, the magic method for plus is double_add_, for minus it is double_sub_, etc. When we use the plus, minus, etc. operators, the corresponding magic methods are automatically invoked internally. A list of few operators and their magic methods are shown on the screen. Hope that you have understood the concept. If you find any difficulty, please watch the previous lesson on OOPS. Thanks for watching. Please like, share, comment and subscribe the channel for more such useful lessons. Happy coding, bye!